Good afternoon, this is Schweitzer, and this is just going to be a pretty short little video, just sort of highlighting a few things about the molar mass of butane. This is a pre-lab video, and this is just to help you get off on the right start. First of all, we're doing a gas collection, okay, over water. Okay, our objective of this lab is to determine the molar mass of butane via gas collection. Now, butane is not a mystery substance. It is a carbon, 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 and all hydrogens. So at this point, you should be able to determine the molar mass of butane theoretically. So this is not a big mystery type lab. You should know what your answer is supposed to be. You just need to add up all the pieces and calculate your molar mass. So this is usually one of the first labs we'll do of just general gas collection. And then likely we will have another one later on where you'll be more involved and have maybe some stoichiometry involved in different things. Okay, but this one is just really just practicing the technique of gas collection, and that's where I want to just sort of zone in on a few things. Our objective is molar mass. Don't lose sight of what molar mass is. It's the grams per mole. So I need two pieces of information. I need the mass and I need the number of particles. The number of particles for gas collection generally comes from Pivner. PV equals nRT. N equals PV over RT. So during the gas collection, we'll be able to gather all these pieces of information. This particular lab utilizes a 5-gallon bucket and filled majority of the way full. You will see a thermometer sitting in here, and then a gas collection tube, which you would then, you would fill with water first, and then you would invert it into this guy. It will stay full. Okay, and then, so I'll draw it full, is going to be full of water. It would definitely not tall enough to not have atmospheric pressure to be able to push up that water. All right, and then we're going to use a lighter full of butane to display some water. Now the lighter, as of right now, and I may get different ones I guess, but here's the lighter, and it has a long tube. This tube here has a long tube on it. All right. This is a tube that would normally belong to a stick lighter. Okay, so it has the tank here, and then the handle here, and then the stick runs out and lights a flame here. So that tube runs up the end here. All right, so here's the deal. This thing here hooks up by a little piece of rubber tubing. This is a small amount of gas that you're going to be utilizing here. So any amount of water will throw off your calculations. You're going to mass this thing beforehand, and I would take this thing off. Take this thing off. It just pops off. And then I would, as you dispense, okay, it's not that long, but get this thing close to the surface and drop your tube in and dispense your gas. Remove it again, and with just the nozzle, weigh it again after. The difference between these weights is how much gas you utilized, and if nothing escaped, that's your top value, your mass. You cannot submerge this thing because it is impossible to dry. Any amount of water will throw you off. So keep it dry above. The tube can get wet, but then take the tube off when you're weighing it. Just weigh just this container beforehand and weigh the container afterwards. Pretty simple there. The next idea is, okay, the mass is pretty easy to do. How do I get all my values for this thing. Okay, now you should be pretty close to doing this on your own, but so I have PV over RT. The temperature check comes from the thermometer. They do want you to let the gas sit for a while, I guess, and the water usually has been around for a while. The volume check, that comes right off of the gas collection tube. And then R is a constant. The pressure. Now the pressure is, well, let's look at this thing for a second. What's the pressure going to be? Well, first things first, as I collect my gas in here, I'm going to redraw this thing below here. So I got my 5-gallon bucket. Okay. I'm going to collect my gas, which displaces water. I want to collect enough gas that I can equalize my two water lines, because I want my water line inside of this thing to be equal to the water line outside of the test tube. In this case, my pressure of my atmosphere is pushing one way, and then the pressure of the gas inside of here is pushing against the pressure of my gas, plus any height of water that you may have here. Okay, I don't want there to be any height. I want the height to be 0, so I got to account for that. Then my pressure of my atmosphere equals the pressure of all the gases that are in here. Now we would still call that pressure of gas what we call wet, meaning it contains water vapor as well. Pressure wet equals the pressure of your gas, okay, plus the pressure of the water vapor. Okay. You know your temperature that's inside this thing. Go to your online, whatever, data tables, look up the water vapor pressure for water at that temperature, subtract it off the total to reveal the pressure of just your gas. This goes in right here. So we got a handful of things there, and should be pretty much ready to rock and roll in that lab. Do a couple trials if you can. Thank you very much.